Pretty little guitar part. Okay, so what I'm going to do is we're beginning a discussion of the chain rule, which is an important rule to learn in calculus when you're learning how to do derivatives. But before you do that, you have to really review the idea of a composition of functions that you generally learn in college algebra, pre-calculus classes, because this relates well to the composition of functions. So I'm going to do, in this part of the video, a review of composition of functions. Okay, so to begin with, a composition of functions, you denote it with f composed of g. Looks like it's spelling fog. The open circle is the symbol for composition of functions. And we write it like this: f composed of g of x is the same thing as f of g of x. So it's really meaning that you're taking whatever g of x is and then you're evaluating that into the first function f. And the domain of f composed of g is the set of all numbers x in the domain, such that g of x is also in the domain of f. So the thing is, g of x must be defined before f of x can be defined. Okay, so if g of x is undefined, then you're not going to be able to get anything for f of x. So just a couple of things I want to go through. A good way to develop the idea and just review the idea of composition of functions is just look at a table like I've got here. So the idea is I'm given different x values. I'm given what the value of f of x is, what the value of g of x is. They're always defined. So what this means, if you read this, this would be f of negative 3 is equal to 11, and g of negative 3 is equal to negative 8. So that's how you read that table. So when you're doing a composition of functions, I'd recommend that you start these problems like this. Write it in this form up here. Just write it as f bracket g of 1. And when you do a composition of functions, what you're doing on that is you're evaluating at g of 1 first, and then you're plugging that into f. Okay, so if we do g of 1, here's x equals 1, g of 1 is 0. So this problem is really the same thing as f of 0. Then you can look at 0, and f of 0 would be 5. Okay, so that's the idea behind that then. Okay, next one is f composed of g of 2. So if I do this, I would start off by writing this like this. And f of 2, or g of 2, if you look at g of 2, that would be negative 3. So you have f of negative 3. And then if you go to x equals negative 3, f of negative 3 would be equal to 11. Okay, so that's how that goes. All right, so you're just starting with the inner function, getting that result, and then evaluating the first function, in this case f. Now you can also evaluate a function of itself. You can compose g of itself. So again, I would write this like this. I would write this as g bracket g of 1. Then just go through and find everything. Let me erase all these check marks and stuff here. So if I'm doing this, g of 1, here's 1, g of 1 is 0. So this becomes g of 0. Then you identify x equals 0, and g of 0 is also equal to 1. Okay, so that's a good way to review composition of functions. So I'm going to have you pause the video, and I'll just give you a couple of problems to work on. There's probably not much on here that's going to be troubling to you, I don't think. So let's just do like this. Let's just do f composed of g of, let's say 3, like that. See what you get there. And then let's just do f composed of f and let's say, I got to be careful when I make these up too. I think I need to go, let's see. Yeah, we can go like this. Just do the same thing, 3. Okay, so pause the video and just, as soon as you're done, check and see if you get the same answers I get. Okay, so here's what you should have gotten. I wasn't trying to trick you on A. I just wanted to see what your thought process was. If you do f composed of g of 3, again, you do this. You do f evaluated at g of 3. And if you work this out, of course, g of 3 is going to be negative 8. And then you got to do f of negative 8. But see, negative 8 is not in the domain. Okay, that's not one of the values I gave you. So all you could say is it's not defined. All right, and that will happen sometimes. You will get an undefined answer if you're working with a composition of functions. The next one is just f composed of f of 3. And again, the way this one works is like this. Here's x equals 3. F of negative 3 is negative 1. So now we do f of negative 1, which is 7. Okay? All right, so let's move to another stage of this. I'm just going to review the main topics that you encounter in composition of functions. Okay, so now what we're going to do is work with specific functions and not a table. So I'm giving you two functions. I'm given f of x is equal to 2x squared and g of x equals 1 minus 3x squared. So to start this off, what you do is you do f of g of 4, like that. And then we just need to do g of 4. And I'm going to do that the side of my paper and just evaluate that. So if I do g of 4, I'm doing 1 minus 3 times 4 to the second. So that's 1 minus 3 times 16. That's 1 minus 48, so that is negative 47, like that. And then when I go back to the main problem, well, I'm going to replace g of 4 with what it's equal to, which is negative 47. Okay, so you start with that function on the right, g, get that answer, then you evaluate that or plug that into f. So f of x is 2x squared, so I'm going to do 2 times negative 47 to the second. Pretty big number there. I'll just pull out my calculator for that one. Oh, come on, behave. Make this a little bit bigger so I can see what I'm doing, the old man here. So I'm just going to put in 2 times negative 47. Close parentheses to the second power, and then that'll give that evaluation on that. Okay, so what we're getting is 4,418, like that. Okay, so got that. And let's do one more like this. So now let's do this backwards. I like to do this backwards just to see if we would get the same answer. That kind of depends on the function. So when you start this off, you would write this as g of f of 4. Now what we got to do is work out f of 4 at the side of the paper. So f of x is 2x squared. Plug the 4 in there to get 2 times 4 to the second. That would be 2 times 16, which is 32. Now put the 32 back in, so you'll have g of 32. Now that goes into g, which is 1 minus 3x squared, so that's 1 minus 3 times 32 to the second. Okay, and I'm just going to do this on the calculator. You follow order of operations. You could put this in one step on the calculator, but just kind of a quick little order of operations review. That would be 3 times 1,024. You do exponents, then multiply. So now if I do 3 times 1,024, that will give me 1 minus 3,072. And then you can get the answer from there. Okay, so that function evaluates at negative 3,071. Okay, so what I'm going to do is I'm just going to give you a problem to do, 2 problems to do. If you want to try this, otherwise you can move ahead in the video if you want to, but I'd like to just kind of give you an opportunity on this to see if you're good with this. So let's do like g composed of f of negative 1. And then a second one to try here. Let's compose something with itself. Let's do like f composed of f of 2. Okay, so pause the video and then come back and see what answers you get on these. Okay, so if you tried out these 2 problems, I got negative 11 on the first one, and I got 128 on the second one. Okay. And I'm going to move on from here, and you can pause the video if you need to look over what I did on those problems. Otherwise, let's move ahead, and then I'll review really one additional idea. Okay, and this is where it really relates well to the chain rule, is where you kind of build a function out of a second function. So when you're doing a composition of functions, you're building a new function out of two functions, okay? So we're going to do this both ways. I've given you two functions here, and we're going to work with the composition in both directions. So let's start by working out f composed of g of x. And the way that goes when you do this is, it's a good idea to write it again like we were doing as f bracket g of x. Okay, and what you're really doing on this is you're taking g of x and you're plugging it in to that first function. So f of x, what I like to do is kind of build a framework for this. F of x is something squared plus 4. Now what we're going to do is we're going to drop g of x into it like that. So we're building a new function. We're taking g of x, squaring it, and adding 4. Okay, we're kind of taking one function and plugging to the other. Well, we know that when we square a radical, that undoes the operation of square rooting. That just gives you x minus 2 plus 4. That would be x plus 2. Okay, so that's the answer on that. Okay, now what I'll do on this one is we're going to do it backwards and just see if we get the same answer. So we got g composed of f of x. Okay, that could be written as g bracket f of x. And again, what we're going to do on this is you write down the first function. That's what I'm saying. Write down what g of x is. G of x is the square root of something minus 2. And then what you're going to do is you're going to plug whatever f of x is into that. So f of x is x squared plus 4. So that plugs in like that then. Okay, so I've got g of x was square root of something minus 2. All we did was just plug the f into that x right there. Then if we work this out, we're going to have square root of x plus 2. And there ain't anything you can do on that. That's simplified. So that's as far as we'll take that then. All right, so that's a quick refresher on how to do a composition of functions, plugging one into the other. And most of the time you get different answers. This is what we would say, composition of functions is not commutative. You don't always get the same answer if you do compose something backwards. If you do, then there's something kind of special about that. Okay? You start getting into one-to-one functions and stuff like that. All right, so that'll end up the first part of the video. That was just a quick review of composition of functions. That will help you to understand the chain rule, hopefully. All right, good luck.